Chapter 7, Kubernetes Fundamentals for Spring Boot. This chapter covers moving from Docker to Kubernetes, deploying Spring Boot applications on Kubernetes, understanding service discovery and load balancing, building scalable and disposable applications, establishing a local Kubernetes development workflow, validating Kubernetes manifests with GitHub Actions. In the previous chapter, you learned about Docker and the main characteristics of images and containers. With build packs and Spring Boot, you can build a production-ready image in one command without even having to write your own Docker file or install additional tools. With Docker Compose, you can simultaneously control multiple applications, which is convenient for architectures like microservices. But what if a container stops working? What if the machine where your containers are running, the Docker host, crashes? What if you want to scale your applications? This chapter will introduce Kubernetes into your workflow to address issues that Docker alone cannot. As a developer, it's not your job to configure and manage a Kubernetes cluster. You would probably use either a managed service offered by a cloud provider such as Amazon, Microsoft, or Google, or a service managed on premises by a specialized team in your organization, commonly known as the platform team. For now, you'll use a local Kubernetes cluster provisioned with Minikube. Later in the book, you'll use a managed Kubernetes service offered by a cloud provider. In our daily job as developers, we don't want to spend too much time on infrastructural concerns, but it's critical to know the basics. Kubernetes has become the de facto orchestration tool and the common language for talking about containerized deployments. Cloud vendors have been building platforms on top of Kubernetes to provide a better experience for developers. Once you know how Kubernetes works, it'll be straightforward to use those platforms, because you'll be familiar with the language and the abstractions. This chapter will walk you through the main features of Kubernetes and teach you how to create and manage pods, deployments, and services for your Spring Boot applications. Along the way, you'll enable graceful shutdown for your applications, learn how to scale them, and learn how to use the service discovery and load balancing features provided by Kubernetes. You'll also learn to automate your local development workflow with Tilt, visualize your workloads with Octant, and validate your Kubernetes manifests. Note: the source code for the examples in this chapter is available in the Chapter 07/07 Begin and Chapter 07/07 End folders, which contain the initial and final states of the project. See this link. Section 7.1, Moving from Docker to Kubernetes. With Docker Compose, you can manage the deployment of several containers at once, including the configuration of networks and storage. That is extremely powerful, but it's limited to one machine. Using Docker CLI and Docker Compose, the interaction happens with a single Docker daemon that manages Docker resources on a single machine, called the Docker host. Furthermore, it's not possible to scale a container. All of this is limiting when you need cloud-native properties like scalability and resilience for your system. Figure 7.1 shows how you target a single machine when using Docker.
Figure 7.1. Docker clients interact with a Docker daemon that can only manage resources on the machine where it is installed, called the Docker host. Applications are deployed as containers to the Docker host.
You learned in Chapter 2 that we change our point of view when we move from a container runtime like Docker to an orchestration platform like Kubernetes. With Docker, we deploy containers to an individual machine. With Kubernetes, we deploy containers to a cluster of machines, enabling scalability and resilience. Kubernetes clients use an API to interact with the Kubernetes control plane, which is responsible for creating and managing objects in a Kubernetes cluster. In this new scenario, we still send commands to a single entity, but it acts on several machines rather than only one. Figure 7.2 shows the logical infrastructure when we use Kubernetes.
Figure 7.2. Kubernetes clients interact with the control plane, which manages containerized applications in a cluster consisting of one or more nodes. Applications are deployed as pods to the nodes of a cluster.
These are the main components shown in Figure 7.2. Cluster, a set of nodes running containerized applications. It hosts the control plane and comprises one or more worker nodes. Control plane, the cluster component exposing the API and interfaces to define, deploy, and manage the lifecycle of pods. It comprises all the essential elements that implement the typical features of an orchestrator, like cluster management, scheduling, and health monitoring. Worker nodes. Physical or virtual machines providing capacity such as CPU, memory, network, and storage so that containers can run and connect to a network. Pod, the smallest deployable unit wrapping an application container. Now that you have a good understanding of the Kubernetes infrastructure, let's see how you can create and manage a Kubernetes cluster on your local machine. Section 7.1.1, Working with a Local Kubernetes Cluster. In Chapter 2, we worked with Minikube, minikube.sigs.k8s.io, a tool for running Kubernetes clusters on local environments. We used the Minikube CLI to create a local Kubernetes cluster relying on the default configuration. In this section, you'll see how to define a custom configuration for Minikube that you can use when initializing a new local Kubernetes cluster for deploying Polar Bookshop. Note: if you haven't installed Minikube yet, refer to the instructions in Section A.3 of Appendix A. Since we run Minikube on top of Docker, remember to start the Docker engine first, then make sure the default cluster is not running by executing the Minikube stop command. From now on, we won't use the default cluster. Instead, we'll create a custom one for working with Polar Bookshop. With Minikube, you can create and control multiple clusters identified via profiles. When no profile is specified, Minikube falls back on the default cluster. Warning: running the examples on a local Kubernetes cluster requires Docker to have at least 2 CPUs and 4 GB of memory. If you are using Docker Desktop for Mac or for Windows, and you need to increase the resources assigned to the Docker engine, refer to the product documentation for instructions on how to do that for your specific operating system. See this link. Let's create a new Kubernetes cluster named Polar on top of Docker. This time, we also want to declare the resource limits for CPU and memory.
See this code?
You can get a list of all the nodes in the cluster with the following command.
See this code?
The cluster we have just created is composed of a single node, which hosts the control plane and acts as a worker node for deploying containerized workloads. You can use the same Kubernetes client, kubectl, to interact with different local or remote clusters. The following command will list all the available contexts with which you can interact.
See this code?
If you have more than one context, make sure kubectl is configured to use Polar. You can verify which is the current context by running this command.
See this code?
If the result is different from Polar, you can change the current context as follows.
See this code?
For the rest of the chapter, I will assume you have this local cluster up and running. At any time, you can stop the cluster with Minikube stop-profile Polar and start it again with Minikube start-profile Polar. If you ever want to delete it and start over, you can run the Minikube delete-profile Polar command. In the next section, you'll complete the setup for your local Kubernetes cluster by deploying a PostgreSQL database. Section 7.1.2, Managing Data Services in a Local Cluster. As you learned in Chapter 5, data services are the stateful components of a system and require special care in a cloud environment due to the challenges of handling their storage. Managing persistence and storage in Kubernetes is a complex topic, and it's not usually the responsibility of developers. When you deploy the Polar Bookshop system in production, you'll rely on the managed data services offered by the cloud provider, so I have prepared the configuration for deploying PostgreSQL in your local Kubernetes cluster. Check the source code repository accompanying this book, Chapter 07/07end, and copy the content of the Polar deployment/Kubernetes/platform/development folder into the same path in your Polar deployment repository. The folder contains basic Kubernetes manifests to run a PostgreSQL database. Open a terminal window, navigate to the Kubernetes platform development folder located in your Polar deployment repository, and run the following command to deploy PostgreSQL in your local cluster.
See this code?
Note: the preceding command creates the resources defined in the manifests within the services folder. In the next section, you'll learn more about the kubectl apply command and Kubernetes manifests. The result will be a pod running a PostgreSQL container in your local Kubernetes cluster. You can check it out with the following command.
See this code?
Tip: you can check the database logs by running kubectl logs deployment/polar postgres. Running Kubernetes services with Helm. A popular way of running third-party services in a Kubernetes cluster is through Helm, helm.sh. Think of it as a package manager. To install software on your computer, you can use one of the operating system package managers like apt, Ubuntu, Homebrew, macOS, or Chocolatey, Windows. In Kubernetes, you can similarly use Helm, but we call them charts instead of packages. At this stage in our cloud-native journey, using Helm would be a bit premature and perhaps confusing. To fully understand how it works, it's essential to acquire more familiarity with Kubernetes first. For the rest of the chapter, I'll assume you have a PostgreSQL instance running in your local cluster. If at any point you need to undeploy the database, you can run the kubectl delete-f services command from the same folder. The following section will present the main Kubernetes concepts and guide you through deploying Spring Boot applications on your local cluster.